Hello and welcome to Pre-Algebra with Miss Betsy. Today we are going to be talking about how we find the volume of prisms and cylinders. If you're following along with my text, I'm in section 12.6. It's called Volume of Prisms and Cylinders, and I'm on page 423. The text that I'm using is Pre-Algebra for Christian Schools, and it's published by Bob Jones University Press. I'm using the first edition. Before we get started, I've got our What Do You Call A for the day. So it's what do you call a fossil that doesn't want to do any work? It's lazy bones. So we've been talking about surface area up until now, and we know that the area, just in a real practical, real-world application, would be a flat surface and how many square tiles it would take to cover that surface. And the tiles are square because they have the same dimension, length and width. And they're called unit tiles. It could be, maybe this is square inches, maybe it's square feet, maybe it's square meters, maybe it's square centimeter, but area is two-dimensional. It's a flat surface that you're filling up with things like floor tiles. What we're going to be talking about today, though, is volume. And volume is like the old sugar cubes that they used to have. It's how much air, if you will, it would take to fill up a square box. And I looked around, tried to find a good example of a unit cube for you, and I couldn't find one, so you're going to just play along with me on this. This is my Spanish box of some Spanish curriculum. It says, speak in a week. Well, it's a pretty interesting curriculum. Things that you can go through and learn a lot of stuff. But speaking in a week, no, I don't think so. But the reason that I picked this is because this is a square face on it. The height and the width are the same. Now, if we had the same height and width and depth, if we had a cube this side, this would be what they would call a unit cube. And volume would be how many of these cubes it would take to fill up the space in a box. Whether that box would be rectangular, whether it would be square, maybe it would be the shape of a pyramid, maybe it's a cone. But the volume is how many unit cubes it takes to fill up a given object. And just like area is square units because you have length times width, length times width, so you have square units because the units are used twice. Volume, there are three dimensions. In the most basic generic formula for finding volume, it's length times width times height, so you have cubic units, because the units are used three times. So whether you're measuring inches, feet, miles, centimeters, millimeters, area is square units. Volume is cubic units. And what happens when you are finding the volume of an object, since with area here, you basically have length times width, you have two dimensions, regardless of what the shape. And I bet you this little house figure here doesn't even show up. Well, it does almost. I think it does actually show up. The area is just the flat surface. Volume, you add a third dimension to it. You pull a point out here in space, and that's the height, you know, the tallness of your object. So what volume essentially is, you're finding the area of the base, and you're multiplying that by the height. So that's what our book is going to use as a way to explain to you how to find the volume of a prism. And remember, all a prism is it's a three-dimensional object with square sides. It's not a cylinder. A cylinder is a three-dimensional object with round sides, like a pipe, a section of a pipe that's cut off, or an oatmeal container. So your book is going to tell us that the volume of a prism is simply this. It's the area of the base times the height. So what this big B is, let me write this right here. This is the area So if you have a square, you find the area of the square, multiply it by the height. You have a triangle, you find the area of the triangle, multiply it by the height. And that's really a very, very straightforward way of figuring out straightforward calculations that will allow you to find this volume. So let's go ahead and look at this example. Example 1 says to find the volume of a triangular prism. Now fortunately your book does these drawings for you and I don't have to do them, but let's see if I can come up with some form of a triangular prism. Okay, and I'm not making a triangular prism. See, it doesn't take me long to forget how to do this, does it? I am very much in awe of those people who are able to just draw, sit down and sketch something in 3 dimensions. I am most definitely not one of these people. Here's the top of our triangular prism, and this here indicates that we have a right angle. Now we're going to draw the sides of this straight down. And then we have a second square, second right angle down here at the bottom on that inside. So what we have here is a triangular base, triangular top with 3 sides that are rectangles. So we would know that if you were doing the surface area, you have 1, 2, 3, 4, 5 areas that you would find the surface, find the areas that would combine that. But we're not doing surface area, we want to find the volume. And the way that you find the volume of this prism is you find the area of the base and you multiply it by the height. So let's go ahead and see how we have our figure here labeled 15, 10, 9, 12, 9, 12, 15, 10. And they're using as their units centimeters. So we have 10 centimeters, 15 centimeters, 12 centimeters, and 9 centimeters. And our problem asks us to tell us what the volume of this object is. Now, how do we find volume? Volume is the area of the base times the height. So we have to know how we're going to find the area of the base. We have to know what the height is. The height is from the top triangle down to the bottom triangle. The height is 10 centimeters. So let me just go ahead and put that the height over here is 10 centimeters. Now, I'm also going to put that in order to find the area of a triangle, that area is 1/2 the base times the height. Now notice we have 2 different bases. This capital B, that's the area of the base. This little b here is whichever leg of the triangle we're saying is the base. Now you have to remember, looking at this, that you have a base of a triangle is what it sits on. The height is the height that is going perpendicular to the base. So we'll just say that the base of the triangle here is 9 centimeters and the height is 12 centimeters. And this is the height of the triangle. And this other height up here, This is the height of the prism. Well, now I've used 3 of these dimensions. I've used 9 centimeters, I've used 12 centimeters, I've used 10 centimeters. What about this 15 centimeters? Well, what dimension exactly is being used there? I mean, what is that? Well, this is the length of the side of the triangle that is directly opposite the right angle, so that makes this the hypotenuse. We don't use the hypotenuse when we are finding area. We don't use the hypotenuse. You'd use that in the Pythagorean theorem. So that piece of information right there is extra information, so that they're putting it in there. Make sure that you can clearly and properly identify the parts of your problem. So we could show, instead of putting here the area of the base, we could put in the formula for the area of a triangle, but I want to go ahead and do this just exactly the way that they've copied it for you. So they start out by saying that the volume of this prism is the area of the base times the height. And then they just go ahead and put off here to the side. They say, okay, remember guys, the way that you find the area of a triangle is it's 1/2 the base times the height. So what they're going to do is they're going to put that information in parentheses. It's 1/2 times the base, which we said was 9, times the height, which we said was 12, and then we're going to multiply all of that times the height of this prism, which is 10 centimeters. And that's how they've done their work on page 423. I wish that they would have actually put in, instead of just substituting directly, that they would have put in that the volume of this triangular prism, that the volume would be 1/2 B times H, in parentheses, times the height of the prism itself. The reason I think they didn't do that is so that you wouldn't get confused by having 2 lowercase h's and didn't know which height went together. Okay, you do your arithmetic now, and you have volume is equal to 6 times 9, which is 54, times 10. So the volume of this triangular prism is 540. Now, am I finished at this point? No, because volume and area always have units associated with them. What units do we have here? We have centimeters. Now, since we're talking about volume, volume always has cubic units. So the volume of this triangular prism is 540 cubic centimeters. Now, you're not going to have to draw a sketch. They're going to give you the sketch. You do have to be able to pull out and say, okay, I need this piece of information, this, and I need this. That 15 centimeters right there, I don't need it because I'm not doing anything with the Pythagorean theorem, so I don't need to know anything about the length of the hypotenuse. So this is what an example of what they would call a triangular prism. It has straight sides on it, it has right angles. You find the volume of a prism by finding the area of the base. In this case, the area of a triangle is 1/2 the base times the height. Multiply that by the height of the prism. Okay? Now let's go on and we're going to find the volume of a cylinder next. And you remember, if you watch the video where I'm showing you how to find the surface area of a cylinder, we showed you this, a cylinder. I had a soup can. It had a circle at the top, circle at the bottom, and then when you unwrap the label, it was a rectangle. And so you would find the surface area of a cylinder by finding the area of the 2 circles and finding the area of this rectangle. But what we want to do now is, how do we find the volume of a cylinder? And once again, the volume of this cylinder, volume is going to be the area of the base times the height. Well, what is the base of a cylinder? Well, I just said it with our soup can. We've got a circle down, which is the base. So how do you find the area of a circle? Do you remember this from earlier in the chapter? The area of the circle was pi r squared. So if the volume of a cylinder is the area of the base times the height, then the formula to help you find that allows you to determine the area of a cylinder is exactly this. So volume is equal to pi r squared h. Pi r squared is the area of the circle times the height of the cylinder, giving us volume is equal to pi r squared h. And in pre-algebra, they assign for you the approximate value of pi to be 3.14. So all you have to do when you're calculating the volume of a cylinder is be able to remember that the area of your circle is pi r squared, and then know what your height is. So there is a question on, it's example 2 on page 424, and it says, find the volume of the cylinder. Use 3.14 for pi. So let me go ahead and sketch this cylinder for you over here. This is the radius, and it's marked as 4 centimeters. And the height here is 7 centimeters. So we have our cylinder. Is this radius or diameter? Well, it's radius because it starts in the middle. So we're simply going to substitute in for our formula. The volume of this cylinder is going to be 3.14 times the radius squared, which is 4 centimeters, times the height, which is 7. So what are we going to have now? Volume is 3.14 times 16 times 7. Go ahead and punch that into your calculator, and that will give us a volume that is approximately 351.68. Notice that I said the volume is approximately 351.68. That's because we're using an approximation for pi, so it's never exactly right, because you can't come up with an exact value for pi. Volume is always cubic units. The units that are being used here are centimeters. So it would be 351.68 cubic centimeters will be the volume of the cylinder. Now let's just go ahead and think, well, what would we do if we had been given the sketch and it showed a line like this, and it told us that that measure was 6, well, I wrote meters. This measure here was 6 centimeters. Would you just plug that 6 into this formula here? No, you wouldn't do that, of course, because this is asking for area. This line going through the center of our circle here is the diameter, so you cut that in half. It would be 3 centimeters would be the radius. That's the only thing you really have to be very careful for when you're dealing with the volume of a cylinder. That's making sure that you differentiate between radius and diameter. So go ahead and work these problems. Look carefully and make sure that you're able to figure out what is the height, and that some of these problems are going to have extra information, extra measurements in there that are not relevant to finding their volume. So just be on the lookout as you're doing your work. I'll see you next time.